Alright, ladies and gentlemen, welcome back again. Now we're going to be talking about graphing other trig functions, specifically this time cosecant and secant functions, and of course we'll be doing those by hand. But again, to get a bearing here, if we graph the cosecant on our calculators, we get something that looks very much like what you see here on the screen. Okay, now again, with the tangent and cotangent that we did recently, we got these vertical lines in here that, again, depending on your calculator, you may or may not see yourself, but what these are actually representing are some asymptotes that we've got throughout the graph. Again, the y-axis has got another one right here on it, and then again a little bit further down here. Okay, in case it's not real obvious, okay, somewhere between 2 and 4 here, this is actually pi, like this is negative pi over here. So notice it's just a little bit past the 3, so that's your 3.14, etc. Alright, so here's 2 full periods of this thing, from negative 2 pi to positive 2 pi, and we got these nice asymptotes, and we got these kind of parabola-looking things. Okay, but of course, let's talk about a little bit just so we can see exactly where all this comes from. And so here we go. Alright, so what I'd like to do is now use our unit circle and graph y equals cosecant, but in the interest of having a good frame of reference here, I'm going to purposely go ahead and graph y equals sine. So in green over here, I'm going to graph y equals sine of x, just to kind of show where this thing evolves from. Alright, so anyway, I go from positive 1 to negative 1 here, and let's see, since my period's 2 pi for sine, I'm going to go pi 2 pi, and then kind of split the difference at 3 pi over 2 and pi over 2 right there, and do the same basic thing going to the left. This will be negative pi and negative 2 pi. To avoid muddying the diagram up too much, I'm going to not label the half increments of pi. Hopefully you don't get offended too badly by that. I'll put a 2 and a 3 up here, and a negative 2 and a negative 3 down there. And let's start rolling. Okay, now sine, of course, let's change color again just because it's fun. Alright, sine, of course, goes to the origin, and at the pi over 2 mark, it should be up at positive 1, back to pi 0, 3 pi over 2 gets us down to negative 1, 2 pi gets us there, and basically just finishing this, we can generate a sine curve pretty quickly here. And I'm kind of purposely going to do it as just a little bit of a dotted sine curve, because I'm not actually graphing sine right now, or at least my intention is not to graph sine, my intention is to graph cosecant. But let's see how these two guys relate to each other. Alright, so here we go. Alright, so again, taking our nice values here, basically what we're doing is taking the reciprocal of sine anyway. So right here, sine is 0 at 0. I'm sorry, sine. Yeah, sine is 0 at 0. So then I take the reciprocal of that, and, well, that gives us undefined, so there's an asymptote, so not too much of a shock. Okay, we can split some hairs here, but if we just kind of go up to the pi over 2 point, we get 1, and, well, the reciprocal of 1 is 1, so we actually get this other dot right on top of the other one. Okay, as we continue down here, we're back to sine is 0 by the time we make it to pi, so we get, again, another undefined, so another asymptote, that's why that shows up there. Okay, 3 pi over 2 goes to negative 1, the reciprocal of negative 1 is negative 1, so hey, look at that. And then again, as we cycle back here to hit 2 pi, okay, it's the same thing as 0, so it's a sine of 0, reciprocaling gets us an asymptote again. Okay, and without having me laboriously go through that whole thing, let's just go with the asymptotes over on the left half of this thing. Okay, now what's going on to generate these kind of parabola-esque sort of things if we kind of think about in between? Okay, let's imagine like the pi over 4. Oh, pi over 4, right here, my sine value ends up being root 2 over 2. If I do the reciprocal of that, that's just the regular root 2, which is about 1.4. Alright, if you don't believe me, type root 2 in your calculator, it'll be about 1.4. So anyway, as we get here, well, there's 1.4 would be about here-ish, give or take a little bit. Okay, strangely enough, when we get over to 3 pi over 4, which is going to be about right here on my x-axis, okay, I also get root 2 over 2, so that's going to give me the root 2 again, so the 1.4-ish. Alright, and if you imagine, as we kind of continue this, we could keep generating other points in here, and even the asymptotes, hopefully it makes a little bit of sense as we get close to pi here, my sine value becomes very, very, very small. And of course, if I take the reciprocal of a very, very small number, I get a very, very large number. So hopefully that's explanation enough to see how we're getting this parabola shape here. Okay, every time we take the reciprocal of one of these small numbers in the y-coordinate, okay, we generate a larger y-coordinate. Once sine makes it up to 1, the reciprocal is simply 1, so we actually have this point in common, but then as sine starts dipping, this one starts getting bigger. And again, that generates that basic parabola-esque shape. And the same argument holds here. Even though we're reciprocaling negative numbers, that means we just get bigger negative numbers, if you will. And again, that basic argument lasts through the entirety of this thing. So we get this shape, which notice is basically a series of parabolas whose vertices, if you will, are the tops and bottoms of the sine curve. Okay, if you can accept that, I'll skip the argument for the secant graph as compared to the cosine graph. Hopefully this is argument enough that if we graph cosine and then we did secant, we would just basically do the same thing, graph a cosine, and then at the tops and bottoms of the cosine we could just do a bunch of parabola sort of things. Also notice that the asymptotes happen at the center line. So whenever this guy hits a center line, it's really a 0, and you're taking the reciprocal of 0, then that generates the asymptote. So anyway, there's that. I won't bother doing this with cosine and secant. If you need me to do that for you, please ask in class. I'll be happy to run through with those. Things to do as you're graphing cosecant or secant by hand is, well, first of all, we're just going to graph the reciprocal function. Okay, and then, as I was kind of saying in that last thing, we're going to just draw vertical asymptotes wherever we hit our center line. Okay, now please keep in mind that is the center line, not necessarily the x-axis, because if we had some kind of a vertical shift, then the center line is no longer on the x-axis. So please do keep that in mind as you do this. And then we're going to draw our, and I know they're not exactly parabolas, but I think that's our best descriptor right now for this, for each max or minimum of the reciprocal function. So again, at the tops and bottoms, the crests and the troughs, we just throw some parabolas, and we got a complete graph. Alright, so now I'd like to do a couple of these just to kind of play the, here's what it looks like when you do it for real game, and hopefully it's good enough for you to follow and make sense of. So here we go. Okay, so we're going to graph 3 secant x plus pi over 2 by hand. Alright, so again, since I'm dealing with secant, what I want to graph is y equals, and I want all the bells and whistles here as far as doing my cosine. So I'm going to graph 3 cosine x plus pi over 2. And basically that's going to be my framework from which to draw the secant function. So here we go. Alright, so again, thinking about the things that I need to do, my period is still going to be 2 pi, but I am shifted left pi over 2. And then my amplitude is 3 for my cosine graph. Alright, and I don't have a vertical shift. So I'm going to want 3 units here. One other thing as I'm doing this, secant is going to go for parabolas up and down from where the cosine graph is, so I don't want to take that 3 all the way to the top, because then I'm basically not leaving enough room for the cosecant, or sorry, the secant parabolas that we're going to have. But in the time being, I can put 3 up and down there. Again, if it helps you to throw in those vertical lines, sorry, horizontal lines, that's probably not a bad idea. Okay, again, my center line's my x, so I'm not going to bother doing that one. Okay, and this one's a little bit dicey because my shift left is pi over 2, and since my period is 2 pi, my quarter period is also pi over 2. So I just have to be a little careful labeling things. So again, I'm going to do kind of the color switch thing to not get things confused. So basically here, my starting point at negative pi over 2 for my cosine graph, again, I'm not even thinking secant yet, is going to be there. Let's switch here. So then my first quarter period puts me at the origin again. My next one puts me at a positive pi over 2. Next one over here, pi, and then 3 pi over 2. Okay, and again, I take this guy to the left, so there's 1, 2, 3, 4 marks for my quarter periods. So here I'm at negative pi, negative 3 pi over 2, negative 2 pi, and then finally negative 5 pi over 2. Alright, so then from here, I should be able to generate a relatively decent cosine graph. Let's pick a nice pretty color for that. Alright, so again, here's my starting point. Cosine starts at the top of the curve, and there's no reflection to flip them upside down. So my cosine graph is going to start here. Next point goes to the center, all the way to the bottom, center, all the way to the top. Okay, likewise, we can take this guy to the left. So bottom, or sorry, middle, bottom, middle, top. And again, because this is not exactly what I intend to graph, pretend I actually hit that dot. Okay, we can go through here and almost make our cosine curve kind of an asymptote of sorts. Alright, and so I'm still not ready to graph my cosecant or my secant yet because I need my asymptotes. And again, here we are, anytime we have a middle line, we're going to have our vertical asymptote. Because again, it's really cosine is 0 right there, and if I want the reciprocal of 0, well, I'm looking at an asymptote. So here we have this, looking all pretty and cool and all that kind of stuff. Alright. Okay, so now I've got the cosine, I've got my asymptotes drawn in the middle of the graph, so now, as my final answer, if you will, okay, cosine basically just gives me secant as a whole bunch of parabolas going right from where we started. Again, I am using the word parabola incorrectly, but again, hopefully I get my point across by using it. Okay, one little thing we got going on here is I've only got half as I've gone for that whole 2-period thing. So if that's one of those things that messes with you, you don't like the fact that we have kind of a half of a parabola hanging loose over here, we can basically, instead of using this bit on the left, we can come over here, extend our graph a little bit over here to 2 pi, and from there, actually let's go to the 5 pi over 2 as well, because if you don't like the look of this, we can always get that there. I guess I didn't need that. That gives us our other asymptote, and then if you want a solid 2 periods without having a broken piece, you can just do that and kind of ignore this left piece over here. So again, just kind of depends on what your opinion is on the whole matter, but there would be the green. So the green stuff right here is my official graph. The other stuff is just kind of the framework upon which I've drawn it. But that's what secant looks like. Alright, so now let's take a look and do a cosecant one that's been modified. Alright, so I've got this -1/2 and I've got this +1. Again, really what I want to do is graph y equals -1/2 sine x plus 1, and then get the framework in order, and then as a very, very last thing, actually draw my parabola-esque curves to finish it off. Alright, so first of all, again, the things I have to worry about are my period, and my period is going to be 2 pi. I got to worry about my amplitude, which is going to be 1/2, but remember, because of that negative sign, we are going to be reflected over the x-axis. And then we've got a shift, which is up 1. Alright, so starting to get my sine graph together. Again, I'm not even worrying about the cosecant yet. Okay, now again, with a shift up 1 and an amplitude of 1/2, I kind of want to make my 1 relatively high here. And I'll put a 2 up here, and then those 2 other tick marks will be the +1/2 and -1/2. So again, maybe here's my horizontal lines. Right now, hopefully I left enough room to make this thing look reasonable, because remember, again, I have to go above and below my graph to actually do the cosecant that I'm looking for as the final answer, but here we go. Okay, I've got the shift up 1 taken care of, so now I'm looking for my starting point in the center, if you will. And there was no horizontal shift, so that's a good thing as far as making this easy. And so I've got my sine, which will normally start at the middle. Let's change colors here. Okay. My period being 2 pi, my quarter period is going to be pi over 2. So again, that'll get me my tick marks, and more specifically the labels on them. So pi over 2 pi, etc. And of course, since we're still on the y-axis, it's pretty easy to get the other ones. Basically just mirror the numbers with negative signs on them. Alright, so again, I didn't put a center line. Let me put that in right now so I don't forget. Alright, and now again, I'm just drawing a very bogus sine graph. Alright, and sine normally starts in the middle. I kind of already put that dot down there, but remember now we got this guy flipped upside down, so instead of coming up, this guy's going to come down. And so down, back to the middle, all the way to the top, down to the middle again, and again, just kind of continue the pattern to the left. And in just a matter of a few seconds, we should have something that resembles a pretty darn good sine curve. Okay, again, not necessarily important that you do that. What's important again is you identify where the center line is so we can draw on our asymptotes. So our center line here, again, remember, not the x-axis necessarily, just the center of the graph. So that gives me an asymptote here right on the y-axis, and then again right here at pi, and then over here at 2 pi. Okay, mirroring that over here in the negative half. Okay, and again, we've done an awful lot of work, and not a single bit of it really is our cosecant. But now let's switch over here. Now we've got all this framework in place. Now we can say, okay, there's our common point, and draw something that looks reasonable like a parabola. And again, the green here is the only part of all this mess that is actually the graph. Just the rest of it is important, so that we can get this drawn in a reasonable way. So there you go. That's what the graph of negative 1/2 cosecant x plus 1 looks like. Again, just the green. Alright, so there's our assignment. I got a bunch of graphs to do. That 1 through 6 all is just a matching section, so don't freak out over that. But there you go. If you have any questions, of course, ask me in class. See you then.